All right, we are going to talk about what is called a compound inequality, okay? And we've been doing simple inequalities, and a compound just means together, okay? Two key words you look for. You could look for the word and or the word or. And this results in what we call a compound inequality. So let me give you a couple of examples of these. Okay. All right. So the first one here, there's two ways you could write it. You could write it out in the words. So in words, this would say x is greater, right, than 2. And, keyword, x is less than 6. Now, one way you can write that is joined together, all right? So you could just make it one whole statement, and it would say, and when they're written like this, I always read it from the letter, right? So if you read it from the letter, it would say the same, x is greater than 2, and it's also less than 6. On a number line, what that would look like, let's say we got 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so on the number line, you would have 2, right? Open circle, I'm reading from the letter, is greater than, so that would be going this way, wouldn't it? So it's greater than 2, and it's also less than 6. That would be going that way. So what we're talking about are all the numbers that are in between 2 and 6 in this particular problem. Okay, the second type of inequality is what we call the OR. Okay? And again, you'll see the word OR. Okay, the graph looks a little different. Here it says x is less than 2, or x is greater than 6. So x is less than 2, or it's greater than 6. On a graph, what's that going to look like? Is, let's say, let's make a couple of numbers here so you can get an idea of what the graph looks like. So if it's less than 2, again, open circle, going that away, right? Or it can be bigger than 6. So you'll notice how the graphs differ, okay? So what I want to do next is I want to take a few problems, get them into this format, and then graph them. All right, so we're going to work on a couple of these. Now, this is, if you remember, this is the end statement, okay? Most of the time they're written like this in the compound form. So if we look at this and we work from the middle out, so you want to get the variable by itself. So if we're going to try to achieve that, wouldn't we add 1? However, we're going to add 1 to the left-hand side, and we're also going to add 1 to the right-hand side, which will give me 3x is greater than 9, and it's less than or equal to 12. Now the last step to get x by itself is divide by 3. And we'll divide each side by 3, which makes x greater than 3 and less than or equal to 4. And the way that looks is, let's say you got 0, 1, 2, 3, 4, 5, 6. And you read it from the middle again, so x is going to be greater than 3. We'll start off at 3. And less than or equal to, so we're only talking about all these numbers in between, fractions, decimals, anything in between here, including 4. All right. All right. If you want to try this one, you can. I'll give you a second because I'm going to do it. So if you want to shut the video off, try it, come back. I'm giving you the chance now. All right. So x by itself again, right? We are going to add 10. So remember, we're adding 10 to both sides, right? And what happens is we'll have basically our answer now, right? So 10 minus negative 9 is 1, right? So x is bigger than 1, and it's less than 5, right? So let's see what that looks like on the number line. It's going to look similar to the previous one. Okay, so again, read it from the middle. X is bigger than 2 and less than 5. So again, we're just talking about anything in between this little area here. All right, now we're going to look at the two OR problems. And basically, they're just simple inequalities separated by the word OR. So in this case, you're just going to do each of these problems by themselves, right? So we're going to divide by 4, right? Okay, so that would be 5. Or, in this problem, by 3, right? So 3 goes into 21, what is that, 7 times? So let's get that on the graph now. That's going to look kind of the opposite of this, right? So we've got, I don't know, we got 0, 1, 2, 3, 4, 5, 6, 7, 8, okay. So if we're at 5, right? Closed circle, because we're including 5, so we have to be less than 5, or we can be bigger than 7. So basically we're talking about all the numbers would fit inside one of these, this one or that one, except the ones in the middle. All right, and the very last one, pretty simple, -2, right? So we got R is less than 10, or if we subtract 5 from 19, we got R would be greater than 14, right? All right, so let's get the appropriate numbers on the graph. I don't know, 8, 9, 10, 11, 12, 13, 14. Okay, so to finish this off, R is less than 10, open circle going to the right, or open circle going to the right. So again, all the numbers would work except the ones in the middle here. All right.